Hi, today we're going to review the VIA Digital Operations Solution Suite, which is built on top of the VIA Digital Transformation Platform. The main purpose and the main use cases supported by the Digital Ops Solution Suite center around moving operations centers from a system-oriented approach to a service-oriented approach. So instead of concerning yourselves with single network elements or network connectivity, things like routers and switches and such, we're really looking from a service-oriented approach. What a subscriber of your services would care about as well. So are they able to interact with the service? Are they able to have a high quality of service? Is it functioning the way that it's supposed to? That way operations centers are more closely in touch with the customer experience. So in this example, we're on the incident analysis screen, which is the default login screen for the Digital Operations Suite. This is something that could be up on the large boards of a network operations center or used by a fixed agent itself. But a lot of the value, as we'll demonstrate in here, is really closed loop automation. This is a demonstration system. It is live data. It is real data. However, it's limited in its data history, and of course, the automated actions are turned off. But I'll explain those as I walk through. So this first example would be an incident that we have collected. It's first important to explain what an incident means in the VIA language. So this is a collection of one or many individual anomalies. We collect incidences at the service level. So in this example, we're looking at the over-the-top video services by a service provider. So something like a Netflix or a Hulu that's offered directly from a service provider. And the incident that we picked up happens to be around the initialization of that application itself. So as you see here, it's a failure to start a stream. So failure to stream a piece of content. So we collect incidents by aggregating up anomalies that occur within a service view. So whether that's anomalies on the network layer, whether that's anomalies at the IT side, whether it's anomalies from the application itself, and we turn those into intelligent incidents and we analyze those for root cause and key symptoms. So you see very quickly this pops onto the screen here. It has a duration, a score. It shows if there was a customer anomaly detected at the same time, meaning interactions with the call center. We inherit rules from their current incident management systems like a Remedy or a ServiceNow to determine whether this is an outage or just a hazardous condition. And then we allow for actions to be taken here. Since this is a demo system, those actions are taken off. But the closed loop actions could be as simple as opening a ticket, more complex like automating a message in the IVR system notifying subscribers of an issue, or something even more complex like integrating with an orchestrator to spin up new virtual network elements, or to take actions like rebooting devices and things like that. So from the incident analysis of all of the anomalies that were fired during this time, what we're seeing is we enrich this very simple metric, failed stream starts, with everything we know about it, where the subscribers were when they were trying to use the service, what content they were trying to stream, and so on and so forth, and how they were connected to the network and things like that. So we very quickly see that this seemed to be centered around this specific channel, so C-SPAN HD. So not only are we detecting these in real time, so within minutes of these issues occurring, we're detecting them. We're also scoring the severity of them, so different actions can be taken based on the severity. We're integrating with those downstream systems, so automated actions can be taking place like getting the right people on a conference bridge to solve the problem if we can't automate the fix. And then, of course, reducing the unnecessary troubleshooting by giving them the key symptoms or the root cause. So there's no need to troubleshoot across all of the different pieces of content. We have it pretty much down to a specific channel. So this is probably related to the content delivery network or the piece of content itself that's having the problem. Okay, so what I want to do now is explain what's happening in the background. Obviously, we're generating baselines here. That's what you see by this dark blue line. And we're bringing in the actual events themselves. That's what you see by the vertical histograms here. We're using some complex algorithms here to generate those baselines and generate the anomalies, and then finally a scoring methodology to score them so we set the proper priority. If I were to now go into the back end a little bit, I want to show you what we're doing. So this isn't just a handful of different metrics that we're bringing in. We're actually bringing in thousands of different metrics here to enable this solution and describe these various services. So I can continue to scroll down, and you're going to see things across the network side like load balancers, across the application side, again across the specific IT infrastructure like CPU utilization, memory utilization, and so on and so forth, that go and describe how a particular service or services come to bear. So how do we onboard these? So this is basically once a metric has been registered with the system, and I'll show you how you can quickly register that with the system here. So we have a set of what we call analytic data flows, or ADF models, that allow you to ingest data sources very, very quickly and then register those parsing jobs as Spark jobs, if you will. So here are, as an example, some of the metrics that we saw. Failing streams was the one that we were looking at there. So it's a streaming data set. It comes from a Hive table from the source system, if you will. And I'll look at the schema here real quickly and see what we do. There's no getting around parsing data. Parsing data is parsing data. Having to extract it from the source and then transform it into the models you need is just work you simply can't get around. But if I look at the properties of this really quick, you'll see that here's where my various sources come from. So you just configure these blocks. They're pretty simple. So you say where the sources are, and you go and grab the source data, if you will. It will actually go and create a schema for you, so we can look at that schema if we need to. And once it generates the schema, we just need to adapt that schema. So here is the sample data that will generate the schema for you, and then you can just adapt it if you need to change things from integers to numbers and so on and so forth. So once that parsing is done, you simply plug it into these existing blocks that occur, and it will start doing all of the parsing routines that you need to do. So as long as you can get that source data, so I would just grab, say, a new streaming source from here. As long as you can get that source data into the format necessary, we can just plug it into these streaming models here, and it will actually go and complete the parsing for you and go all the way down to two different areas. One, it puts it into history for persistence and for the ability to do baselining and things like that. And then also streaming to do anomaly detection and other analytic routines for it. So this is how a partner or a service provider themselves could bring new metrics into the solution, register those metrics, and then start to actually have it processed. And it will go all the way from the source to the glass, including all of that anomaly detection, all of the incident detection, and everything that I showed on the first screen will be done automated, as long as you can pull in and parse that first data source, which turns it into a metric. Now, alternatively, you have the ability to select and use our existing anomaly models, and we have a number of them to choose from. We have a whole slew of different anomaly and baseline models, and it just kind of keeps going and going over here. Or you can create your own, which we'll show you here in a second. But as an example, if I wanted to look at this anomaly model that we're using today, and again, this is fetching it from that last screen that we saw, so there's nothing you necessarily need to do. But if you have your own intellectual property that you want to register with the system, that you want to have as a reusable block, we basically can just create a new block here using our SDK, or you can just edit an existing block that we have here and save it as a new block, and I'll show you that. So the first thing that we do for the anomaly detection here is we have various different configurations. We can do the window size. So this is a 30-minute window size in 5-minute increments. How far back you want to look in terms of baselining to fill in any data gaps that may exist and things like that. So you set some simple configurations, and it's going to actually process the baselining and anomaly detection algorithms that live in here. This is generating Scala code. All of these blocks and all of the parsers that we showed before are actually generating Scala code. So if I look behind this here, I can actually look right into the model, and I could see where the anomaly detection code actually starts here and everything that's involved in doing the baselining. None of this was necessarily had to be written explicitly because we used models that that we brought into the system. But if you wanted to, you can just kind of come in here and start editing and drop in your own model in Scala. Or you can write that in a number of different languages, and then we can import it into the models here. So if you have your own algorithms you prefer to use, and you want to edit the algorithms we have, it's very simple to do that and onboard a new anomaly detection model. And so you can, like I said before, this is where you can start to register your own IP, and this is where you can start to enable your own models. And it would be just like setting up the new flows like we talked about before. You bring in a new data source here. From that data source that you ingest, you want to do some parsing on it and some anomaly detection. So you're going to bring in your parsing block to, I don't know, get rid of 0 values, aggregate data up to 5-minute intervals. Again, without writing code, just with simply using some of the parsing logic that we already have built in here. You can compute anomalies to it, and then you can give it some target that you want to send it to. You want to send it to a feed that can be picked up by other data sets. You just wire these together, and you can register this and save it as an analytic data flow, just like we did here before. Okay. Now, of course, we also offer some other tools and quick ways to build UIs. So as an example, this is a very quick UI that allows us to look at the results. This is basically a what-if scenario. If we introduce new algorithms, how would certain metrics perform across those new algorithms? Would we catch, like we're showing here, we're catching the incident before customers start calling in. So it allows you to do a number of what-if type of analyses. And if you wanted to, just like you can edit those ADF models for the processing, you can also edit these models to build a dashboard if you want. So you have these various different visual flows that you can build to create your own little what-if scenario dashboards and stuff. So it's a very similar model-driven environment, and you just have the page configuration that you can do, whether you want it to be side by side, you know, any sort of these grid formats and so on. You would just change these and save the page configuration there. So pretty simple. But of course, if you don't want to go into those models, like I showed you before, we do have the ability to just use a simple configuration tool. So on that what-if analysis that we were doing as an example, where we showed the page for it, you can easily construct a little configuration table. So instead of going into the model like I showed you and adjusting the window sizes, you can just grab a different window size from here, pull it down into this table, and it allows you to go and start doing some basic configurations and things like that. So it's very easy to go from this, which is a fully offered solution that we have packaged up already, allow you to extend it by just bringing in new data sets into our existing analytic data flows, which as long as you can get it to basically this model here, it will send the data out for analysis in real time and also persisted for history. You can create your new analytic data flows if you want to launch new use cases or new solutions. You can adapt and extend existing ones that we have by just editing models here directly and saving those as your new custom models and editing little analytic data flows or, like I said, algorithms here. And then again, of course, you have another set of tools to go and build yourself some UI dashboards. All right. Thank you very much.